Hello and welcome to another coding session. How about that? How about that? Bet you didn't expect that to happen. Bet you didn't. So today I wanted to do a random one-off stream, even though today is not Friday. Well, I mean, it doesn't really matter whether it's on Friday or not. I wanted to do a random one-off stream, and I wanted to develop something rather interesting, something that I wanted to implement for quite some time, for several years already. Here's the thing. I worked at a company that used the thing that I'm about to implement today, at least attempt to implement today, as the interview exercise. So they would give that as an interview exercise for like several days to like a candidate, and then the candidate will return the solution, then they will evaluate the solution and decide whether they want to hire them or not. So I actually got hired before that exercise was introduced in the company, so I never had an opportunity to actually solve it. The exercise is rather interesting. It is rather interesting. The exercise is to implement a mini Excel. I do not remember the precise problem definition, so I'm gonna sort of improvise on the definition itself. But I'm gonna use the same idea. And the idea is the following. You have an input. So you have to write a console batch program. Just a simple console batch program that accepts a file and spits out another file. So, and the format of the file that it accepts is rather interesting. It's a CSV file. Right, so we're gonna have input CSV. So, and the CSV file has to form a table which is similar to the Excel table. Right, so in our case, we're gonna use a header for the columns with letters, right? So we're gonna have columns A, B, C, D, E, F, and so on and so forth. So, and then goes the rows. And in the rows, you can have different values. You can have numbers, right? 2, 3, 4, 5, 6. You can have, you know, some sort of strings, hello, world, and so on and so forth. Maybe we're going to be a little bit relaxed in the amount of columns that you can have. So for instance, we're going to look at the row with the maximum amount of columns and basically autofill the rest of the cells for shorter rows. Right. And another interesting thing is that you can have formulas in the cells of the table. So you put equals in there, and then you can refer to a specific cell, like for instance A1 plus B1, right? And then you can have A2 plus B2, and so on and so forth. So you have this CSV file, and you have to feed that CSV file into your program, something like, I don't know, let's put it this way. Right, so we're gonna call our mini Excel mini cell, right? So it's gonna be mini cell, and you feed that program in here. And what this thing should do, it should parse this CSV file, parse all of the formulas, and evaluate all of the formulas and fill in the corresponding values and output all of that into the output CSV. Right, and this is the entire exercise, believe it or not. So the difficulty of this exercise comes from the fact that you need to parse the CSV file. Then within each CSV file, you need to parse mathematical expressions. Then you have to evaluate these mathematical expressions, and they can depend on each other. And you also need to detect cycles, right? And if there is a cycle, you have to properly report it. And that's the whole exercise. So it's basically an engine of Excel, but without UI. So, and they would give you like a weekend to implement this entire thing. So you're supposed to implement it over a weekend and then give them a solution in any language, by the way. It was a company that didn't care about what language you program in. They just wanted programmers who can solve these kind of problems. So, and again, I never had a opportunity to actually solve it because I got hired before this problem was introduced as an interview problem. I actually solved a completely different one. So the one that I solved is not that interesting, is not as interesting as this one. So this is basically what I want to implement today. Does it sound interesting? Hopefully it does. Looks like a good task for, yeah, it is actually good. And the company really didn't care about, you know, programmers who know specific languages. They really didn't care. They wanted programmers who know computer science and who can learn any language, so they can basically take them and give them any language, and then they could work in whatever project they can. So it was more about the programming skills rather than specific language skills. So that's why all the interview questions were like that. And you were allowed to use whatever language you want. Want to program in C? Sure, give a solution in C. Want to program in Haskell? Go ahead. We have people who understand Haskell. They can evaluate your solution. So it was a really interesting company. I could do that company was that company. Yes, it was that company. So anyway, is that company, you know what company I'm talking about. So it has a crazy CEO, but it's an interesting company nonetheless. Maybe that's why it's so interesting. Does that involve compiler and parser knowledge? Well, it certainly involves parser knowledge. It depends what you mean, what is a compiler knowledge. Not really sure. Participants count must be very high then. Probably, I don't know. Anyway, so let's actually try to implement this entire thing. So let's try to come up with a very simple example that we can sort of put into our README. So in here we have two columns, right? So let's actually align everything by a comma. Align by comma, and there we go. So we have something like this. So this is going to be our example. So A1, B1, and this one is going to be 3, I suppose. This one is going to be 4. All right. So it's going to be README. Gia, what's up? Hello, hello, how are you doing? Mini cell, right. No, this is not a banned word on Twitch, okay? Please don't report me to Twitch stuff. This is not the banned word. It's just, it stands for mini Excel, okay? Not trying to offend anyone, it's not a forbidden word. It's a mini cell. So, the idea is to implement a simple, a batch program that can accept a CSV file that looks like this. So do we even have a CSV highlighting for this entire thing? I'm not even sure. So then I'm gonna go, so it has to be something like input CSV. So this is going to be README. So this is what we accept, and like this, and outputs CSV. So what's going to be the output? Let's try to determine. So we're gonna, so first thing is the column, right? The second thing is the row. Row starts with 1, like in Excel, right? So A1 is going to be 1, B1 is going to be 2, right? A1, B1. So, and 1 plus 2 is going to be 3. You see, I still remember simple arithmetics. Even though in the previous stream I kind of demonstrated that I don't understand simple arithmetics, I still do remember some of the things from simple arithmetics. So, and this one is going to be 7. And outputs something like this, right? So this is going to be like that. Basically, a simple Excel engine without any UI, right? Without any UI. So that's basically the main idea of this entire thing, right? This is basically the entire idea, and let's actually create, you know, the entry. We're gonna use C today, because why not? It's a very underrepresented language on the science and technology section, so let's actually give it a little bit more attention. So, and for building, we're going to be using no build, right? For building, we're going to be using no build, and no build is a build tool that I build myself, right? So you can find the link to this build tool in the description if you're interested. No build tool, right? So that's what we're doing today. Okay, so to use no build, we'll need to download the header file and put it in here. So this is going to be the raw thing, wget no build. So I'm going to create no build.c. I'm including no build.h. Then I'm defining no build implementation, because no build is an STB style header only library, right? And here we're gonna have this thing. Recently in no build, by the way, we implemented a very cool feature. It's a self-rebuild. Right, so we implemented self-rebuild. So the way, basically, it makes it so when you update .c file and rerun the program will rebuild itself because it detected that there is a new version of itself. So the way you enable that feature, you use a special macro called go rebuild yourself. Go rebuild yourself, and you provide the command line arguments, right? So, and basically it will use command line arguments to detect what program you run, then compare it times between the source code and stuff like that, and it will rebuild itself and run a new version of this thing, right? So I can even demonstrate you something like hello, right? And then we're going to return 0. So then I'm going to bootstrap the build tool, gcc o no build.c. There we go. And if I try to run no build, right, it just says hello. Right, it just says hello. But this is not what we want from a build tool. What we want from a build tool is actually an ability to build our program. So it's going to be cc, then we're going to provide the C flags, then we're going to provide the O file, right? So this is going to be mini cell, and the input file is going to be main.c. So for the C flags, we're going to define things like WO, W extra. We want to enable as many warnings as possible because C is a very weakly typed language, right? It's a statically typed language, but it's at the same time it's very weak, weakly typed language. Essentially meaning that a lot of types, convert coerce to each other, which is like, quite dangerous and leads to a lot of mistakes. Right, so because of that, we want to enable as many warnings as possible. So in terms of the standard, I'm going to use the latest standard in here, and I want to be pedantic about it, so it is portable. And I'm also going to enable all of the debug symbols so we can debug our application. Right, and look, now I'm not going to even rebuild the build tool. I'm only going to rerun the build tool. And the build tool detected that the source code of itself modified. It renamed itself to an old version, build a new version, and run the new version. So we actually implemented that feature on the stream. If you're interested how you can implement a self-rebuilding program, I recommend you to check out the following video. And for people who's watching in Twitch, here's the channel where you can look into that. So YouTube even recommends me this video. It's actually pretty cool video, I think. I think it is pretty cool video, so you can find it in here. So I'm gonna put this thing into the description. Program that rebuilds itself. Right, there we go. So we implemented this thing. Hey Tokenizing, I know that Vim is practice, but do you recommend some content to start like Vim tutor? I do not recommend you to think about text editors too much. Text editors don't make you a better programmer, so if you put too much effort into learning text editor, you will put less effort into becoming a better programmer. So that's basically my wisdom to you. So don't waste your time on editors. Just pick whatever editor you're comfortable with and focus on actually creating something, on on actual programming. So these days you can actually pick things like Visual Studio Code, and it's actually quite convenient. It has a lot of convenience features, like it allows you to search the entire project, jump around. So don't focus on this kind of stuff. Like, it's not important. It doesn't make you a better programmer. I'm really sorry to tell you that, but yeah. Makes sense. Thank you. You're welcome. You're welcome. Just don't worry about it. So really, like, the editor doesn't make you a cool programmer. If you see some cool programmer using a particular editor, just because you learn that editor doesn't mean that you will become as cool as that programmer. It's just like doesn't mean that. So if you use a different editor, you maybe can become even cooler than that programmer. So the thing that makes a programmer a good programmer is practice in programming, not practice in text editor. Seriously. So it's a complete misconception. So use Nano. Yeah, use Nano. Like, I know a lot of cool programmers who use Nano. So don't focus too much on this kind of bullshit. Focus on actual programming. That's what's important. All right, so we have this kind of thing. Now, okay, so we have a build and stuff like that. So I think I'm gonna go ahead and create a repo out of this thing. We can also do something like this. Hello mini cell, right? So hello mini cell. So on top of that, in no build, I'm maybe going to implement the following thing. We're going to implement some subcommands. So we're going to assert if you have at least one argument, we're going to compare this argument with different strings. So it's going to be strcmp, argv0, and for instance, run, right? So, and in that particular case, on top of just building the mini cell, we might as well also run the mini cell. Why not? So otherwise we can also print something like panic. This thing is unknown subcommand, right? It is an unknown subcommand, and we're gonna put argv. It's actually not argv0, it's supposed to be argv1. Argv1 Zulu, right? So argv1 Zulu. All right, so, and on top of that, if I do run, it automatically runs it. So see, so now we have a subcommand, it builds the application and automatically runs it. That's pretty cool. All right. So the time has come to create a repo out of that. So the things we're gonna ignore executables such as mini cell, no build, and no build old, right? So this is the executables that we're going to ignore in here. Maybe it would also make sense to create src folder, if you know what I'm talking about. Right, and put all the source codes in there, right, and it fails because there is no such thing in here. So we can put this thing like that. God, I love self-rebuilding thingy. Like, it's such a useful feature. Like, I needed that for a long time, because every time I was working on my build script, I was always worried, did I recompile it or did I not recompile? Now I don't have to worry about it, because the script detects whether it needs to be recompiled and recompiles itself. It just goes and rebuilds itself. It's so beautiful. I absolutely love this feature. My God, should have implemented it like earlier, because it's such a like a quality of life improving feature. Like, it almost makes it as convenient as scripting languages, right? So because this was the main advantage of using scripting languages, right? You don't have to rebuild your script, right? Because you just run it, and you always run the latest version. So can you do all that you do in C in Rust? This is a wrong question. The right question would be, why couldn't you do the same thing you do in C but in Rust? That's the right question. Your question doesn't really reveal more interesting information. Okay, so but the second question actually makes you start thinking, really, why? What are the things, what are the specific things that will prevent me from doing the same thing, but in Rust? Let's find out. Let's Google them. You know, so the half of the work is asking the right question. Asking the right question makes you think and search for specific things, and that's how we learn. You see what I'm talking about? Right? That's what's important, I think, in programming, please. All right, so yeah, let's actually initialize the Git repo. And let's do a committee. Ready, set, a go. And I'm gonna create a repo mini cell in here. Mini cell. So do we have any good description? A simple Excel engine without any UI. Right, simple. So this one is going to be public. And let's do something like this. So this is going to be add origin, a boom, push to the origin. And let's push it right into the repo. So the initial source code is available already. It is already available. What's up, Columbetka? Yeah, I decided to do a little bit earlier. So the reason why I was doing like late streams is because I was depressed. So I wanted to always stream like around this time, actually. And now finally I managed to stream like in the time that I meant to stream. Okay, so here's the source code, and you can find the source code in here if you're interested. So yeah, this is the mini cell, and there we go. So I'm gonna put the link to the source code in here. So source, let's put it this way, mini cell source code. Right, so this is the mini cell source code, and another thing I want to be able to do, maybe I want to put like a quick start in here, quick start. So the project is using no build, yeah, so let's actually give the link to no build system. No build system. Alright, so it's going to be console. Then the first thing we need to do is bootstrap the no build system, and then just run, just build the application, and then mini cell, and we're going to provide the input in here. There we go. So this is the quick start instructions. Add quick start instructions. Right, I'm gonna push that right into the repo. We're gonna push that right into the repo, mate. So the first thing we need to do, we need to be able to accept the input file, right? Because according to the quick start instruction, right, you're supposed to put input CSV in here. Right, so let's try to do that. Int argc character argv. So if so I'm just thinking, it's gonna be fine. If argc is less than 2, then we have to print the usage. We're gonna print the usage to the standard error because an error is in place, right? So when an error is in place, it is better to print everything to standard error output, so the user can redirect everything related to the error to a separate file, and everything that is not related to the error to, for example, to the screen, right? So that's why it's important to separate them. For the convenience of the user, all right. So, and we need to create this function usage file string, right? So, and the usage right now is going to be actually relatively simple, right? So it's going to be relatively simple usage. Let's actually capitalize it like this: mini cell input CSV, right? And for now, we're not going to accept any options, so we're going to leave it like this. After that, I'm going to print std error, error, input file is not provided, right? Input file is not provided, and we're going to exit with one exit code. So once we've got the input file path, right, the input file path, we need to actually read the whole file into the memory and parse it. Right. So this is a CSV file, but I'm thinking, do I need to have like a proper CSV parsing? So I'm gonna make an executive decision to actually not implement like sophisticated CSV parser with escaping and something like that. So our limitation is going to be that you can't have commas in the cells. Or maybe we're not gonna use commas. You know, because if we're gonna have mathematical expressions, right, the mathematical expressions could be functions, if you think about it, and functions have arguments that are separated by comma. By the way, in Excel, the function arguments, how are they separated? I remember that if condition is a function in Excel. Excel if condition, so it has like several arguments, and I think it was using semicolons. If I remember correctly, I think it was using semicolon. No, it's using commas. Okay. It is using commas. So I think to simplify our life, we instead of like separating by commas, we're gonna separate by bars, right? So this is gonna be bar separated thing. Right, so in that way we don't have to think about escaping commas or anything like that. So it's gonna be completely bar separated stuff. Right. So what do we have in here? Make the input separate fields in the input with bar instead of comma. So this is another thing that we want to have in here. All right, let's go back. And we need a function that would slurp the entire file into the memory, right? So we're gonna have something like content, right? And I want to have a function that essentially just accepts the file path, right? It accepts the file path and returns you the whole content of the file, right? So on top of that, I'm probably going to be using string view to parse the file, so I'll need to know precisely the size of this entire thing. So I think I'm going to pass the size like this. Right, so I'm going to mark this entire thing as not implemented, as 0 not implemented. So this thing is not implemented yet, we're going to implement it later. So slurp file, input file path, here we're going to have something like content size, right? So here's the content size, we're going to pass the content size by pointer. There we go. And if content is actually equal to null, that means this is going to be some sort of an error, and we're going to say something like error could not read file as because of as, right? So, and the file that we couldn't read is input file path, and the reason is located somewhere in error no, and to grab the string that explains the reason, we're going to use str error. Right, something like this, str error. So, and to have all of these functions, we'll need to include string and error no. There we go, if I remember correctly. So, and then here we're going to just do exit. So, the primary reason is going to be that the file does not exist or a folder, right? So let me recompile this entire thing, and we don't have assert, so that means we need to include assert.h in here. Right, do we have anything else? File path, these are unused variables, file path, size, right, so do we have anything else? Okay, so everything seems to be okay. On top of that, I think I want to actually run the mini cell with the input file, right? So I'm going to put input CSV in here, and it will be automatically run with the corresponding file. And you see, it tried to slurp the file, but it failed miserably. Why don't you have extra parameter which tells the delimiter? Because that will complicate the implementation, right? So look, the parser that accepts a parameter is more complex than parser that hardcodes the parameter by the definition, right? You see what I'm talking about? So a thing that is more generic and parameterizes something is more complicated. Not that much, but still more complicated than the thing that simply hardcodes the thing. Right. So the question is, why would I complicate my application when I only started to develop it? You see what I'm talking about? Like, why? Why would I do that? All right, so we need to implement this entire thing. Slurp the file. So we're gonna open the file, right? File, f open, file path. And we're gonna open it for reading as binary. If file actually returned null, right? So that means there was an error. We're gonna handle error in a classical C style by using goto, right? So we're gonna do goto error. And somewhere down there, we're gonna have a section for handling errors. Right, and in here, we're gonna actually deallocate all the resources first, if they are allocated. So if f not equal to null, we're gonna definitely close this file, and then we're going to instantly return null, right? We're gonna instantly return null, okay. So after we open the file, after we successfully open the file, we need to determine its size. So the classical portable way of determining the size of the file is using functions iftel and ifseek. Right. So there are other ways, like for instance using stat, right? But this is not portable. It doesn't work on Windows, for instance. But I think Windows has like a POSIX layer, Win API stat. But I wouldn't recommend relying on this layer. It's kind of a sus layer. So yeah, the most portable way is to actually put the cursor of the file to the end of the file and just take the value of the cursor, and that's basically the size of the file in bytes. Right, so let's take a look at the function fseek. Let's take a look at the function fseek. So essentially it accepts the file itself. Right, in that case it's going to be f. The offset is going to be 0, so offset is from 0, and whence, right, is end. That essentially indicates that you want to put the cursor, reading a file cursor, to the end of the file. Right, and if this entire thing returned negative, right, this is straight up error. There's no reason to even think about that. Right, there we go. So the next thing we need to do, we need to grab the value of the cursor, right? So ftel, and we're gonna put it in here. So it's gonna be something like this. If this thing is less than 0, right, that means it's straight up error. If it is not less than 0, that means it is essentially the size of the file. And for the size of the file, we're gonna allocate the corresponding buffer, right? So it's gonna be buffer malloc, and we're gonna allocate size of character multiplied by m. So interestingly enough, if any errors happen somewhere like between this call and return, we'll have to deallocate the buffer before we can return from this function. So because of that, I'm gonna actually declare the variable somewhere up here, character buffer null, like this. And in an error handling section, if the buffer was successfully allocated, then deallocate it. There we go. So that way, if you reach this section will automatically clean up all of the resources and then return from a function, return a null. So basically we are emulating defer, right? So yeah, as far as I know, I think defer works precisely like this, right? On the compiler level, it just takes your expression and just copies like to this error handling section. And then when you have a panic or when you return, it just jumps to this section and just, you know, collects all the resources and stuff like that. So I think that's what roughly is going on with Go defer, but I'm not sure. I never implemented defer in the compilers. Though we have a series where we develop our programming language, and I do plan to implement defer for that programming language. So maybe at some point we're gonna actually, you know, explore how it works. Hello, the Flit. Hello, hello. Oh, I think we need to update our project command. Thank you for reminding me. So update CMD project something like or one sender So what was that? Implementing mini Excel in C, and we're gonna have something like a source code, right? So here is the source code, and the source code is mini cell. There we go. So I'm gonna put this thing in here, and hopefully that will update the project command appropriately. There we go. So now we have a link to the source code of the thing that we're developing in here. Okay, so this is basically a simple emulation of defer, right? If buffer turned out to be null, we're gonna instantly just go to error. There we go. So after we allocated memory, we have to actually set the file reading cursor to the beginning of the file, right? So for that, we'll need to do fseek yet again. Fseek yet again. So I suppose in this case we'll have to use set command, which will interpret fset as the absolute position to set to, if I understand correctly. So this is going to be f. The place where we want to set our cursor is 0, and it's going to be seek set, right? And if this thing returned a negative value, it's an error. It is in fact error. Okay. After that, we're ready to read the whole content of the file. So we're going to use fread function, and fread function accepts the buffer into which we're reading, the size of a single element we're reading, because fread doesn't read a chunk, it doesn't read bytes, it reads elements, right? So you have to provide the size of a single element. For example, if you're reading an array of structures, here you would provide the size of your structure, right? And then the amount of elements in your array of structure, right? And here this is going to be like a structs or something like that. So this is basically what it's designed to do, right? It doesn't read bytes, it reads elements. And the second argument in here is the size of a single element it reads, and this is the amount of elements it reads. So in our case, elements are bytes, so that's why I'm gonna just put 1 in here, and the amount of stuff I want to read is gonna be just m, right? And then we're gonna read that from a file, and it returns how much we read, right? So that's basically what's going on. It returns how much we read. We want to kind of assert that the amount of stuff we read is equal to the amount of stuff we expected, right? I'm going to put assert in here. And also fread may actually return an error, but it doesn't return an error through the result. It cannot do that. So it usually returns the error through ferror. Standard C is beautiful. Standard C library is absolutely beautiful. So completely inconsistent error handling and stuff like that. I absolutely love it. So ferror, what does it return? So suppose ferror tests the error location pointed returning on 0 if it is set. Okay, so if error was set, that means an error has happened, and we're gonna go to the error thingy in here. All right, so after that, we're essentially ready to return from a function, right? So if the user requested the size of the thing, right, we're gonna set the size of this thing like that, and then just return the buffer. And before we return the buffer, we have to close the file. There we go. So that's how you read the whole file into the memory. Right, first you need to determine the size of the file, then you allocate this amount of memory, then you read the whole file into that chunk of memory, and then you return that chunk of memory. If at any steps of this process there was an error, you have to deallocate all of the resources and return with null or something like that. And the easiest way to do that in C is through goTo. It is what it is, and it isn't what it isn't. Is it not? I think it is. Maybe it is not. I don't know. All right, so here we read the whole content. Let's actually see if this entire thing works. It compiled first try, which is kind of sus, but okay. So the next thing we can try to do, we can try to print. Oh, I didn't save the file, didn't I? Okay, so everything is fine. Fwrite. So let's do fwrite. So this is going to be something like this. It's going to be fwrite, and we're going to print the content of this entire thing. So fwrite works similarly to fread, and we're going to just do something like this size. The output is going to be stdout, and yeah. So this one has to be content size, I suppose, right? So, and let's see if it will print the content. There we go. We managed to read the file and print the whole content. So, isn't it POG, my friends? I just remembered that we have to separate values by a bar. Okay, so it's going to be something like this. And there we go. And by the way, every time I refresh this thing, it rebuilds the whole program and runs the program and stuff like that. So, and it takes 100 milliseconds to rebuild everything and start. Isn't it POG? Isn't it POG, fellow kids? So now we need to parse the input. So to parse the input, I'm going to be using my string view library. So the parser is not going to be complete, but that's not the goal anyway. We just need something that is working. You can find this string view library in here if you are interested. So string view library, right, there we go. So I'm going to put it in the description as well for people who's watching all of that shit on YouTube. Okay, so after that, once we read the content and content size, we want to construct the string view. So this is going to be something like input, and in the input we're going to have a count, which is a content size, right? I think it's a content size, and the data is the content, right? So after that, what we want to do, while input is not empty, we're going to chop off a single line off of it. Chop line by... Wait a second, did I download SV? I think I forgot to download this library, so let's actually download real quick. Let's actually download it real fucking quick. So, I'm sorry. So here's the library, and let me see. So it's going to be something like that. We need to include this library, sv.h, and we also need to define sv implementation, right? Because it's a stb style library. So let me open it in here. Chop by delimiter. Okay, so we provide the input, and the delimiter is going to be the new line, right? So, and we're going to try to print each individual line in here, right? So it's going to be something like svfmt, right? So svfmt, svarg line, and maybe in front of this entire thing we could print the, yeah, you know, the place where all of that has happened. So here we have the file name, input file path. So here's the input file path. Also we need to keep track of the line, line 0, like this, ++ line, and this one probably has to be zu because it's the size, and then we're gonna put line in here. All right, so if I try to run this entire shit now, is it gonna work? It does not even compile. So expect size t. Okay, so that means I had to put line somewhere here, right? I had to put line somewhere here. Do we have anything else? I'm not quite sure. So expect, but through argument string view, input file path, zu, and then svarg. I don't quite understand what does it want from me. So if I... Oh, because, okay, it's a line number. It has to be line number. Alright. Has to be a line number, I see. Alright, so, and as you can see now, it actually, you know, parses each individual line, and we can clearly see that everything's fine. Alright, so within each individual line, right, we probably want to parse each individual cell. So to do that, so maybe I should call this like something like column. Yeah, I think I should do col. Oh, was good. So, and then for size to row 0, while line count is greater than 0, we're gonna do ++ row, and this is basically what we're gonna do in here, right? string view cell sv chop by delimiter line, and we split by bar, right? So there we go, we have a cell, and in here we're going to be printing cell. But on top of printing row, maybe we're also going to print the column. What's up, Cybercyclonic? Hello. So the column is going to be rather interesting, I think. I mean, the row has to be like a little bit interesting. We're chopping it off from the line, but to know precisely where it starts from, we need to preserve the start of the line. So maybe I'm going to do something like start line data, and this is basically the start. And what I'm going to do in here is I'm going to take cell data and subtract start. And also I'm making an assumption that well, I mean, I don't think it's that important to actually assert this assumption, so it should be fine. All right, so here are all of the different cells. Right, so our input looks like this. So what it did, it traveled through each individual cell and actually printed it like in a straight form. So it basically straightened up the entire table. So, and we can even jump between all of the cells, you see? So we're basically iterating through each individual cell. So there's like, maybe it will benefit from stripping of the how they called spaces, right? So let's try to strip off the spaces. So this is going to be the thing, and SV trim, we're going to strip off these spaces from both of the sides. And there we go. So as you can see, we are parsing each individual cell, right? Parsing each individual cell, and to indicate that these are the cells, maybe we can print their coordinates, right? Something like ZU, right? And this one is going to be essentially row and column, right? So this is the row and column, and here basically they are. All right, so it looks good to me. So we're essentially parsing each individual thing. That's pretty pogue, not gonna lie. So, yeah. So, interestingly enough, it would be kind of nice to sort of estimate how many rows and columns we have, and then pre-allocate two-dimensional array of some sort of cell structures, if you know what I'm talking about. Right, so we're definitely going to have something like struct cell, right? So this is going to be cell, and within the cell, we're probably going to have just a content, right? So there's just a content, but on top of having content, maybe we're going to have like a different kind of content. So maybe it's going to be cell kind, and then we're going to have enumeration, right? Cell kind, text, right? So just a regular text. So cell kind, I don't know, number. I'm not sure if it makes sense to actually make this sort of distinction, but maybe it does make sense to do that. Cell kind expression, right? So, and these are the cells that start with equals, right? So, and depending on the kind of this thing, we're gonna have a union that can, you know, lead to discrimination of these different things, right? And yeah. So that's basically what we'll need to have at some point. But I'm still not sure if it makes sense to separate cell text and cell number up front. Maybe it makes sense. So basically, when you parse the cell, you try to parse it as number, and if it's not a number, then it's a text, right? But if it starts with equal, it is expression, so you have to parse it as an expression. So we'll also need to implement the expression parser. Okay. All right. Okay. Cool. So essentially, maybe we're gonna do like we're gonna have a function into which you can feed the input, right? And it will do the similar process and tell you the amount of rows and amount of columns, and then you can allocate the necessary amount of memory, right? So let's have something like estimate table size, right? And in here we're gonna provide the content, right? So this is the content, and we're gonna return the amount of rows, and then we're gonna return the amount of columns, right? So this is gonna be the function. So yep, that's gonna be the idea. And in here, I'm gonna just copy paste this entire thing. So the input is gonna be essentially replace input with content. There we go. Then we have a line. This is the line start, and then you have a cell. Right. Do we need to forget the cell? Maybe we do. Maybe not. I'm not quite sure. I think we can just ignore the cell. But the thing we need to do in here is basically constantly keep track of the current amount of rows and current amount of columns. Right, so it's going to be rows and columns. So we might as well actually extract this entire thing in here, and this is going to be our out columns. Right, so if the user requested the amount of columns, we're going to set amount of columns to the current call. I think that's a good way of doing that. So in terms of the rows, we might as well do a similar thing. Right, so we might as well do a similar thing by removing this entire stuff. Right, and then at the end of this iteration, we also need to keep track of the amount of columns, size t, I mean rows. Initially that. If a row is, I think I'm an idiot, because I'm iterating all of that in the wrong order. First thing that we need to iterate is the rows. We iterate in rows and columns. Yeah, we iterate in rows and columns. Okay, so it has to be completely formed differently. So you know what? I think I'm gonna make a small break and make a cup of tea. And after I make a cup of tea, we're gonna continue and implement this function that estimates the size of the table, so we can pre-allocate, you know, all of the necessary arrays and stuff like that. I think it's gonna be beneficial. What do you guys think? I think it will be. So yeah, let's make some break. All right, so I made a cup of tea, and let's implement this function. Or rather, a procedure. Right, let's implement this thing. So what we're going to be doing, we're going to be iterating through the rows. Yet again, I got the order completely incorrect. So while rows is while the content count is greater than 0, this one's going to be plus rows, right? So we're chopping off a line, right? So it's going to be sv chop by delimiter. So this is going to be the content, and we're chopping by a new line, right? So, and we also need to keep track of the columns. This one is rather interesting because so I need to sort of distinguish like the counter and not counter. So I don't know. All right, so here is going to be this, and for line count greater than 0, right? I'm going to be incrementing the count, and within this thing, I'm going to be doing a sv chop by delimiter line bar, right? And that is it effectively. And if calls is less than this thing, we set the calls to this thing. Okay, so that's how we basically estimate the dimensions, the shape of the table in the content, right? And if the user requested rows, we're going to return rows in here. There we go. And if the user requested columns, we're also going to return the columns. There we go. So that's how we estimate this shit. Let's see if this works. Maybe the way we're going to see that is by simply calling this function. Estimate, right? So let's go back. It's going to be something like this. So this is going to be the content input, and we're going to have rows and columns. So it's going to be something like that. Columns. And then we're going to print f this entire thing. Size of the table. Yeah, size of the table. I wanted to say estimated, but it's actually pretty precise. If you ask me. Zooks! Or Zox. I don't know. Yokot Zox. Alright. So my mouse is drifting for some reason, I don't know why. So rows by columns. Let's try to run this entire thing, and the estimated size of the table is 4 by 2. Is that true? Is it true that it's 4 by 2? So there's four columns, 4 rows and 2 columns. All right, so that's fine, but we also need to keep track of like you know, of the header, right? So the first row, the header contains the characters and whatnot. To be fair, maybe we can basically remove this entire thing to simplify the stuff, but I'm not 100% sure. So, and also here's the interesting thing. If I add something like 1, 2, 3, 4, the amount of columns should become 4. Right, essentially, if you have some of the rows that don't have enough columns to fill the maximum one, they're gonna have like an empty value, right? They're gonna be assumed to have an empty value. Right, so if I try to now rerun this entire thing, so now we have 5 by 4, and it was 4 by 3, right? So if I remove this row, now it's 4 by 2, right? So basically make, you know, a little bit, how to say that? So the program is protected from the tables of a weird shape, right? So if the tables have weird shape, we basically take the amount of columns as the biggest row, right? The biggest row defines the whole amount of columns. Makes sense to me, I think, right? So yeah. So if I add more shit in here, this is going to be the whole size of the table. So we're trying to sort of protect ourselves from the malicious data. Right, does it make sense? It makes sense? Hopefully that makes sense. All right, so after that, we need to allocate the cells, right? So we estimated this thing, and I'm going to do something like table, right? So this is the table into which we're going to save everything. Malloc size of cell multiplied by rows multiplied by columns, and if we couldn't allocate this entire thing, we're gonna instantly say something like error could not allocate memory for the table. Right? Maybe the table was too big, or maybe we're running on a very you know, weak machine that doesn't have enough memory for this kind of stuff. All right, so now we have a table, and now we need to fill up the whole table. So how are we going to be doing all of that? So we have different kinds, and the default kind, I suppose, is going to be the text, right? So everything is going to be considered the text. Number is going to be one, expression is going to be something else. So maybe I'm going to introduce a union that basically encapsulates different kinds of cells, right? So we're going to have a type def union, right? Cell as. I like to call my unions as for reasons. So in the text is going to be just view, right? So this is going to be just you know, text. Then we're going to have a number, and I suppose for the number we're going to use the biggest number that we can in 6. Maybe we're going to actually use double. Let's actually use double for everything, right? So yeah, this is going to be the number, right? And the expression, we probably need to have a special structure type for the expression, right? So it's going to be the AST of the expression, and we're going to have different expression kinds, right? So there will be expression kind, def enumeration, expression kind, and what kind of expression, what sort of expression kinds are we going to have? Oh, all right. So one of them is probably going to be expression kind number as well. So it's going to be a number, then cell, right? So this is going to be the cell, because we're going to be referring to specific cells. Maybe it's going to be some variable. Also, it's probably going to be binary operation as well, right? So for now, we're going to have something like this. And cell could be either text, number, or an expression. So, and then we're going to have cell as s. So the reason why I like to call my unions as is because when I have a cell, right, and I want to interpret cell as text, or I can interpret it as number or as expression. So you see, basically this turns into small DSL, domain specific language. So that's why I like to do it this way. If you know what I'm talking about, chat, does it make sense? Does it make sense? I don't know, maybe it doesn't, but yeah. So that's the data structures that I plan to use for this entire thing, right? We're gonna have cells. Cell can be one of three things: text, number, or expression. And expression can be number, a cell, or binary operation. Maybe we're also gonna have functions and stuff like that. Right? Make sense? Hopefully. Anyways, so when we allocated this entire thing, I think we're going to fill the whole table with 0. And what's interesting about the cell, right, is that if you take this entire structure and fill it with 0, it's going to be a valid cell. So kind equals 0 is the text. So that means the 0 cell is the text. And if you take a look at cell as, text is string view. And if you 0 initialize string view, if you take a look at the definition of string view, so the count is going to be 0, right? The count is going to be 0 and the data is going to be null, which means it's going to be empty string. So essentially, if you 0 initialize the whole table, you're going to have a table of empty strings without any initialization. So the only initialization that you did is just 0 initialized it. So I'm following this 0 initialization rule, meaning that if you have a structure, you completely 0 initialize it, it's still a valid structure. So that's basically the rule I'm trying to follow. Does that make sense? Does that make sense, chat? Alrighty. So let's do memset, I suppose. Memset. So 7, right, so we're gonna set the table and we're gonna set everything to, okay, RDB42, thank you so much for 10 tier 1 subscriptions, and everyone who got the subscriptions, welcome to Epic, Epic Mini Excel Club. So it's gonna go for a while, so I don't want to really ruin the YouTube video, so we're gonna skip that. Right, thank you so much for all of the subs. I really appreciate it. So let's continue. We wanted to basically 0 initialize the whole table with 0. So this is precisely what we're gonna do. So it's gonna be size of cell, rows and columns, and everything, as you can see, is 0 initialized. Isn't that beautiful? I think it's beautiful. All right. So after that, we need to probably read the entire table, right? So we need to probably read. You know what? It also would be kind of nice to actually have boundary checks when you try to access the table cells. So I want to have a separate structure, struct table, right? So you have cells in here. Right, and then you have rows, and then you have columns, right? And then you would have something like table cell at, you provide the pointer to the table, and you provide the row, provide the column, right? And essentially this thing will assert different things. So it will check that rows is less than table rows, right, columns is going to be less than columns, like this. So this is a simple boundary check, and on top of that it will also take the cells and row, column, plus column. There we go. So, and it will give you the pointer to the cell so you can modify it if you want to. Right, so it's going to be a little bit more convenient. Right, we wouldn't want to do that like this all the time. So maybe it would also make sense to you know, allocate the table alloc, so you would provide the amount of rows and the amount of columns, and all of that stuff is going to be done in here for you, right? So table alloc, So this is cells. This one is going to be table, table, 0 initialized table, rows is going to be rows, columns is going to be columns, and table cells is going to be that. And if table cells is going to be null, we're going to basically crash, I suppose. We're going to then 0 initialize this entire thing and then return the table. Right, so basically we allocated a new table and then we can essentially query that table like for different cells and whatnot. For different cells. Alrighty, so we estimate the table size and then table alloc. So we provide the rows, columns. By the way, did I forget to... yeah, I forgot to put S in here. Right, so this is our table. And yep, everything seems to be working. So now what I want to do, I want to basically parse the input one more time, right? But fill in all the necessary cells, right? Fill in all the necessary cells. Let's try to do that. So for row 0 input count, maybe we can have a function similar to estimate table size. Right, so it's going to be something like parse table, right? It's going to accept the table, right? It accepts the table and the content, string view content, parse table from content, right? There we go. And here we're doing similar thing, but instead of like just ignoring everything, we're going to be actually populating the table, right? We're going to be actually populating the table. So, do I need to know rows and columns and shit like that? I don't think so. So we're gonna do something like this: content count greater than 0, right? Then we're chopping off a single line, SV chop by delimiter. So this is gonna be content, and we're chopping the new line like this. And while line count is greater than 0, we're chopping off the cell. By delimiter, line bar, right? We also want to trim this entire thing just in case. Trim the entire thing. And for now, I suppose we're going to do the following thing. Table, cell at table, row, column. We need to keep track of the rows and columns. Row 0, plus row, size to column 0. Plus column. We take the cell, and for that specific cell, we're gonna set basically as text cell. There we go. So for now, we're gonna parse each individual cell as text cell, right? So because we want to test this entire thing, and while of course has to be for loop, of course. Of course, it has to be a for loop. All right. So yeah, there we go. We have estimated the table size, then we allocated the table, and then parse the table from the content. Right. So we have 3 steps in here. We have 3 steps. All right. So parse table. So we're going to provide the pointer to the table, and we're going to provide the input yet again. There we go. So after that, I suppose we want to try to print the table back somehow. We want to print the table back. How are we going to be doing that? Well, we're going to be iterating by rows. Row 0, row less than table rows, plus row. Then for size to column 0, column less than table columns, plus column. There we go. And we're getting the current cell. So it's going to be table cell at. So it's going to be pointer to the table, row, column as text. And we just want to print this entire thing, I suppose, right? So we're going to just print this text. svarg, right? Printf. So S, it's actually not S, it's svfmt. We're going to separate everything with bars. And then at the end of the row, we're gonna print a new line. So we're basically, printing the table back. We parse the table and we're printing it back. Okay, so if I try to do something like this, yeah. Okay, that's interesting. So the input, if we take a look at the input, looked like this, and this was the output. We got rid of the spaces in here, and yet again, if I add additional things in here, the parsing process will automatically fill those things in. So as you can see, it works as usual. What does SVFMT do? That's a good question. That is a good question. So we need to understand what is SVFMT, right? So we need to understand what is SVFMT. SVFMT is defined in sv.h, which is the string view library that I developed for my parsing needs. You can actually find this library in here, and if you're watching on YouTube, you can find it in the description. So SVFMT, this is how it looks like. Right. So it's a macro. Right. So SVFMT like this. So that means since it's a macro, it's going to be substituted at compile time to something like this. Right. So essentially it's going to look like that, which is kind of weird. Like you have two strings which are separated by space. Yeah, I made a repo for SV, so you can use it now if you want. I remember you were asking when I'm gonna upload it to GitHub, so it's on GitHub now, so you can use it. So I think it does not even depend on standard C library. Maybe it does. Oh shit, it does. So it should be relatively easy to strip off the dependency on standard C, because I don't really use anything that's like anything that couldn't be re-implemented from scratch. Yeah, string. Like C concatenates string literals, so essentially it will become this. And basically, this doesn't make any sense without svarg. So this is like an old trick that I designed when I was programming in C for quite some time already. It's a trick for defining format strings, format arguments for custom types. Right, so imagine that you have a custom type, right? Something like this. It's only for C. In C++, you don't need this kind of stuff because you have, function overloading and whatnot. But in C, it kind of becomes like a pain in the ass. So imagine that you have a type point, right? So you have a type point which is basically two integers, right? Maybe I'm going to call it vec2, and you want to be able to print your vec2, right? So we have some sort of a position in here, and that position is like 69 for 20. So if you want to print it with printf, you have to do what? Well, you have to decide how exactly you're going to display this entire thing. Then you have to put format arguments in here, and then after that, right, you have to take your thing and painfully just unpack it and put it like that. So this is basically what you're going to do. Put C, and then we can just run it, and there you go, you've got it. So if you have more points, right, so you also have a velocity, right, velocity 23 for 20. So what you have to do, you have to copy paste this thing, right, you have to copy paste this thing, then you have to also unpack velocity x, velocity y, and only then you will be able to print two points. It would be kind of like better if I could provide a single argument in here, something like, I don't know, vec2, and just position, and it would just work. So you know what I'm talking about, like it would be nice. Well, I've come up with the following solution. So basically you define your own format macro. So it's going to be vec2 fmt, and it's going to be basically this thing, right? It's going to be basically this thing. So here's your format macro, and then you define argument macro. So, and the argument macro is actually rather interesting. What it does, it takes your point and unpacks the structure like this, vx, vy, right? It takes the structure and unpacks the structure. So once you have these two, you know, macros, we can even call them something a little bit more short, like v2, right? You can do the following thing. You can remove that, but you can put v2 fmt in here, since the string literals are concatenated, so it's basically a single string literal, right? So, and then here you can say v2 arg like this, and this macro will automatically unpack the structure for you, right? And you can repeat that for both of these things in here. So v2 fmt, and there you go. You also have a v2 arg velocity. There we go. So as you can see, now you have a single format argument and single argument in the list, right? So if you try to run this entire thing now, it still works, and it's quite nice because it basically, you have n amount of format arguments and n arguments. It just like makes sense. So that's basically what I do in here. And I do this trick for my string view as well, right? So string view consists of the count and the data. So to print this kind of thing, you have to use the special syntax in here, which will accept 2 arguments instead of 1. And here I unpack the arguments, and I also convert to integer, and so on and so forth. So that's basically the trick. Does it make sense? Hopefully that makes sense. So yeah, there's like a lot of limitations with this kind of thing. It's not perfect by any means, right? If you have a very complicated type, the error messages could become unbearable, right? So because sometimes they don't explain what exactly happened. You forgot to put arg in here, you're gonna have a really bad time. So, and you better enable all of the possible warnings just in case, right? So the compiler can catch if you know, used incorrect macros and whatnot. And also you can only use it for something that can be easily just unpacked at compile time. If your type is so complex that it requires some sort of runtime recursive traversal of a tree, you won't be able to use this kind of trick in here. So it's kind of limited, but it's okay for small types like you know, points and custom strings, and you know, things that you can just unpack with a macro, right? The fact that it compile times makes it even more poor. Yeah, it's actually pretty poor. You know how I discovered this trick? You know how I discovered this trick? I was working with SDL. SDL has functions. SDL set draw color or something, right? Set draw color. And these are very inconvenient functions. They're very annoying, right? So because they accept colors separately, like each argument separately, which is really annoying. I want to be able to you know, define colors like this. So I have a background, and I want to define like FF AA BB CC, right? So what I came up with a color unpacking macro on hex, which takes a single color in here, right, and basically using the bit operations unpacks each individual component in here. So it will do 0xFF for the first byte, then for the next one is going to be move 8 by 1 like this, 0xFF. So, and I think we can actually do something like this, so it's a little bit easier for us to comprehend this entire thing. So this is going to be the next one, it's going to be the next one, and this one is going to be 2, 3. So in that way, if I have a background color defined as hex value, I can just do the following thing: on hex background, right? And what this thing will do, it will take a single number and unpack this number into 4 arguments for you automatically. And since the modern compilers are very smart, this kind of stuff is going to be probably computed at compile time anyway, so it doesn't matter, right? So and after that, this sort of formatting thing, it was just sort of like next logical step. And yeah, I hope that makes sense. It's pretty cool. So I don't think it's like a pretty good idea generally. It, like, again, it's pretty janky, but we're doing what we can with what we have, right? If C was a bit better language with better way of, I don't know, customizing the format outputs and stuff like that, we wouldn't need this kind of stuff, right? So we do what we can with what we have. So it is what it is, and it isn't what it isn't. Anyways, I think I need to make a small break. So I put a lot of energy into this explanation, so I need to actually catch my breath super quick. All right. So let's continue the implementation, right? So we need to finish this implementation. I wonder if we'll be able to do that before the end of the stream. So we'll see about that. Here we parse the cells and then we print them back. So one of the things I can try to do as we parse the cell, right? We can try to parse them first as numbers, right? Then if they're not numbers, we're gonna claim them to be texts or expressions or something like that. Well, we can also try to first check if it starts with equal or not. So before we can do that, I want to actually slightly change the way I print them. So we're going to try to print the kind of the cell instead of the value of the cell, right? So just to see what's going on in there, right? So cell kind, we need to have a function something like cell kind as string, as sister. So this is how we're going to be calling it. Cell kind as sister, and we can have something like this. Right, and it's going to be simply s. Well, I don't think it makes sense to actually have a separate variable for that. All right, cell kind, right? So here's the function, and here we're going to be returning these kind of things. So it's going to accept the kind of the cell, and it's going to switch case upon different cell kinds, right? So let's also go in here and copy paste this thing in here, like so. And it's going to be a case, and we're also going to query replace this thing with that. Didn't work as I expected. And I want to return, I suppose, one of these things, but we can also, let's actually keep them uppercase. Right, so let's keep them uppercase, and in case of the default situation, this is an unreachable situation, right? So unreachable, reach the unreachable, right? And then we're gonna exit with one exit code, just in case the user strips off the assert. So now, what we're gonna have, we can try to just basically run this entire stuff. Okay, so I need to do that, and as you can see, all of the cells are detected as text cells, right? So they are detected as text cells. So this is something that we want to change, right? I'm gonna go to here, right? And first thing, if the cell, right? If the cell starts with, I think we even have SV starts with. If this entire thing cell starts with equals, right? Equals, that means this is an expression, right? So we're gonna do table cell at table row column. Might as well actually extract this to cell like this, but now we have a collision with this thing, so we need to rename this sort of input. Cell input, cell value. I don't know how to call it, well, let's call it cell value, whatever. So that means if cell value starts with equals, right? So we're gonna set the kind of the cell to cell kind expression. So this is an expression. Otherwise, it's gonna stay text, I suppose, right? So otherwise, it's gonna stay text. And let's take a look. And as you can see, everything was recognized as a text except this 2 cells in here. And if we take a look at the input in here, yeah, there we go, we have only like 2 cells in here. But the reason why we have 4 columns here and 2 here is because we have additional columns in here, and I put them as the test. So if I remove them, right, we only have 2 columns, and the last 2 columns, the last row has only expressions. Right. So, and the amount of spaces here doesn't matter because the spaces get stripped off, so all of that doesn't matter. So the next thing I want to be able to do, I want to be able to recognize these as numbers. I think that's quite important. Right. So, and the way we're going to do that is, I suppose we're going to try to simply parse this thing as a number using str2d. So this thing tries to parse the double, right? So interestingly enough, we have a sized string. And but str2d accepts null-terminated string. Right. So the first thing we'll need to do with the cell value, we'll need to convert it to essentially null-terminated string. The question is how we're going to be doing all of that. So we could pre-allocate the buffer of some sort. But what if the size of the buffer is not going to be enough? That's a good question. We could have some sort of like a stretchy buffer for temporary things like that, which we clean up periodically. And yeah, we could have something like this. But when are we going to be cleaning up? When are we going to be cleaning it up? So we could actually clean it up after we parsed everything, so shouldn't be that big of an issue, I think. Or maybe we could clean it up between the iterations. So let me see. So this one is hard. Let's create like a very simple sort of like allocator that that grows over time. So I want to have some sort of a structure for temporary stuff, right? So something like temporary buffer or whatnot. TMP, right? And this TMP essentially keeps track of the of how much we already allocated, so the actual capacity, then the actual size, and the things that we allocated. So it's going to be some sort of a data. Like, I just don't want to spend so much time just for like a scratch buffer, if you know what I'm talking about. It's just like, yeah, I just want to have a scratch buffer. So maybe we're just going to have like a global, I don't know, like TMP buffer. With a size of a couple of kilobytes. I don't know, like I really don't want to spend too much time on doing that. Right. So, and the way we're gonna do that is right. So we have a cell, right? So here is the cell. So this is gonna be cell value. Send printf and so this is going to be temp buffer. We also assert that the cell value count is actually less than this thing. So, and it's not equal because we need additional null-terminator, right? So this is going to be size of TMP buffer, right? So, and the thing we print in here is essentially the well, we can actually use SV FMT. Yeah, we use SV FMT, and this is going to be SV arg cell value. There we go. So that way, TMP buffer, right? So this TMP buffer is going to be filled with this thing, and we can even try to do that in here only, like this. So after that, we're gonna use this TMP buffer to convert things around. So we're also gonna have end PTR, right? So, and this is potentially going to be the value as number, right? So it's going to be as number, right? And I don't remember how exactly it works. All right, so str to the end pointer. If I enter the character after the last character used in the conversion, okay, so that means if end pointer is not equal to the beginning and end pointer points at does not point at 0, that means we successfully did it. And this is basically the number now. So cell kind number, right? So this is a cell kind number. Otherwise, this is a kind text, and we do as text equal to cell value. There we go. So yep, so I assert everything. So I might as well actually wait a second. I might as well just put this entire buffer literally in here, right, and make it static, so it's not allocated on the stack, right? Okay, so because this is, I think this is literally the only place where I'll need this kind of buffers, so we're gonna just pre-allocate this kind of thing, and we're not gonna support values bigger than 4 kilobytes. I think it's reasonable, right? I think it is reasonable. All right, so this is a cell value. Cell. Did I remove that thing somewhere? Yeah, cell value should be defined in here. Okay. It didn't do anything, so nice. So end pointer wasn't equal to TMP. So I probably made a mistake somewhere for sure. That's very, very interesting. So let's maybe debug this entire thing, right? So I'm not gonna even try to look into the code. If I encounter something that I didn't expect, it's better to just go through like step debugging always. That's what I learned at least, right? So because that will definitely help us to catch the bug. You know what? Maybe in no build, I just got an idea. What if I introduce another subcommand? strcmp argv1 gdb, right? And it will basically call the debugger for me. So it's going to be something like gdb mini cell, right? So there we go. We have different subcommands. It always reveals everything, and now I can do something like gdb, right? And it automatically falls into the debugger. And yeah, that's actually pretty cool. So, and we can break on what? Parse table from content, right? So this can be something like this, and let's just run this entire thing to enable. Excuse me? Oh yeah, I'm sorry. So you have to actually run with input. Yeah, I completely forgot about that. So let's enable this thing, and let's go over. So let's take a look at the line. So line currently points at A, right? So it contains like this. So I don't think it's that important. The most important thing here is cell value, right? So cell value is A precisely. Okay, so it does not start with this thing. So that means we can try to parse it as a number. So, and this is not a number, this is going to be the text. Okay, so next cell value. Next cell value is B. So it's also going to be the text. So I don't see any problem with that. Okay, so here's the text. The next one, okay, so this is going to be that cell value right, cell value is 1, and this one is actually very interesting. Okay, it doesn't start with equals. All right, so we're printing to the buffer. We can take a look at the buffer, right? Take a look at the buffer. So here's 1 in the buffer, and there we go. So if I take a look at what's located in as number, it's 1. I don't see any problem with here. But end pointer, right? End pointer, it's +1. So it is not equal to the temp. Oh, and it has to be equal to 0, right? So if I take a look at the end PTR, right, it is equal to 0. Okay, so I made a logical mistake in here. All right. So I really like the debugger that it sort of forces you to go through each individual little detail that you wouldn't go through otherwise if you wouldn't using debugger. So if you just read the code, a lot of details you would just miss them. But debugger sort of forces you to look into these details, and it kind of encourages you because you can also look up the specific values of this variable. You know what I'm talking about? So, and that's what makes it easier to catch these logical mistakes and stuff like that. So yeah. No builds? You guys talking about no build? If you're interested in no build, you can find it in here, right? It's like a header only library. Monica Life, hello. So yes. So it's not even a build tool, it's literally a single header file. No build is a single header file, but it allows you to write recipes that looks like this. And the coolest feature of this build tool is that it can rebuild itself, it can rebuild its own executable. Right, so it's like using C as a shell script. All right, so we found a mistake, I suppose. Right, so it has to be equal to 0. It's not equal to the beginning, but it has to be equal to 0. Right, and now if I try to run this entire thing, there we go. So we determined the types of the cells correctly. So the type of the first two cells is text. Here's the text and text. Here is the number, and here are the expressions, right? So we detected the types correctly, hopefully. Okay, so on top of doing things like that, we could also maybe print the corresponding value, right? So essentially what I mean is that here is the cell, right? So here is the single cell in here, and depending on the type switch cell kind, right? So here is the cell kind, it's going to be case cell kind. Where is it? Where is it? Okay, so I'm gonna go here. So this is what we've got. Print F. Yep, this is gonna be something like this. In case of a text, I think it has to be svfmt. In case of the number, it has to be lf because it's double. Right, and here we're gonna have svarg. So this is a svarg. Cell as text, right? So cell as text. Then here we have cell as number. And for the expression, we don't have anything yet because we don't know how to parse expressions yet. Okay, so I just want to print not only the type of the cell, but also its corresponding value, right? To sort of demonstrate that we actually know how to do this kind of stuff. Right, so, and it does not compile because I forgot this thing. There's a couple of warnings in here, may fall through. Oh, okay, so let's actually fix that. Thank you, compiler, very cool. Yep, there we go. So, and probably we also forgot to do the following thing, print f. No new line in here, please. So it's gonna be bar, and there we go. So the original input looks like this, and this is what we've got. So there's a text, we identify this is the text, this is the number, and this is the expression. The only thing we need to learn how to parse the expressions. So, yep, that's pretty powerful, I think, not gonna lie. So that's what we got. Expression parsing. We're gonna actually make it as simple as possible. So for now, we're gonna be simply parsing numbers, variables, and single binary operation plus, right? So, and we're gonna only support that for now. And implementing such parser is actually super easy. So once we have that, we're going to implement the whole evaluation engine. I think the most difficult part is going to be evaluation engine, because expressions depend on other expressions in other cells. So that means you need to keep track of different dependencies, and also you need to keep track of the cycles. So that's a little bit more difficult. So I don't think parsing is that difficult. I implemented a language, a programming language that looks like this. Let me actually find. So where is it? BM bang examples game of life. So yeah, nim. I know how to parse this kind of stuff. So, and I implemented it using recursive descent. So all of this is parsed with recursive descent. So I don't think it's that hard. Actually, using recursive descent makes it easier than Flex and Bison and stuff like that. What I found while working with Flex and Bison is just majority of the time you do is just fighting with them instead of solving the problem. So it's just easier to do recursive descent. But again, I don't know. I'm not a compiler developer. Maybe it's not. Anyways, so but from my experience, from my very humble and small experience, it's kind of. All right, so we have that. So we have an expression. And speaking of the expressions, it's going to be rather interesting. So the question is, where are we going to be allocating this, you know, all of the expressions? Where are we going to be allocating them? So if a single expression, yeah. So as already mentioned, we have three kinds of expressions. All right. So maybe I'm gonna even go even further and just say that we're gonna have a plus, right? Right. And then we're gonna have something like expr as, right? Type def union, right? This is a union, expr as. And in here, if it is a number, right, so this is going to be a number, then a cell. So cell is basically this thing. This is the cell, reference to the cell. And a plus is essentially, it has left-hand side and right-hand side, right, I guess. So it's a thing that have like these two things, expression plus, type def struct, expression plus, and we're gonna have pointer to left hand side and right hand side. So that's basically what we're gonna have. So because of that, we need to concern ourselves with allocation, with memory allocation, right? So maybe we're gonna have a specific allocator for expressions, if you know what I'm talking about. Because when you want to parse all of the expressions, you want to just keep allocate. Well, yeah, so maybe since it's a batch program, right? Since it's a batch program, maybe we could just allocate and don't think about deallocating anything, because everything is going to be deallocated at the end of the program anyway. It's a batch program. So this is how, for instance, deprogramming language work, the compiler for the deprogramming language. Deprogramming language. Right, so one of the features of this language is that during compilation, it allocates memory and never frees it. And because once it's done compilation, it will be deallocated by the operating system anyway. So there's a whole talk by the creator of D about memory management and stuff like that. I wonder if I can find it, memory. Oh, here it is. Yeah. So here's the talk. For people in the Twitch chat, you can find it here. And for people in YouTube, I'm going to actually put it in the description as well. So we're going to put it like this. Right. So let me see what's the title. I want to put the title in the description as well. Garbage collection. No, basically, operating system will deallocate everything your program allocated. Right. So at least modern, decent operating system.
Well, a pleasure to.
Right. So it will close all of the files that you open. It will unmap all of the memory regions that you mapped. So you don't really have to think about that. So the only situation when you really need to think about it, if you have like a long running program that allocates a little bit of memory in a loop, and that allocated memory accumulates over time, and that's what we call memory leak. But if you have a batch program that just allocates a bunch of stuff that needs to work, there's no need to deallocate it. Operating system is going to do that for you. So, and you're only gonna create yourself problems if you're gonna concern yourself with this kind of stuff, right? So it will become more difficult. And here's an example. Like I was thinking about this temporary buffer and stuff like that, and it's just, maybe I shouldn't even think about it. Maybe I just can malloc and just leak a little bit of memory in here, but there's no reason to leak memory in here, to be fair. So I think we could just use a single buffer in here. Okay. So for the expressions, we're gonna just be piling them on the heap and forgetting about them. So there's no reason to do that. And if it's going to become a problem in the future, we can create like a Reno allocator or something. So all right, so here's that, and the thing I want to do, right, I want to have a function that parses an expression, parse expr, right? So string view source, right? So, and in here, for now I think I'm going to put assert, indicating that this is not implemented yet. Unimplemented, right? Unimplemented, and we're going to return null. There we go. So interestingly enough, I think for the cell, right? If I try to find the cell, where is the cell? Yeah. So since all of the expressions are going to be allocated in the dynamic memory, we can just store it as a pointer, right? So we have string, number, and a pointer to the expression, and that's gonna be it, essentially. I think. Probably. The problem is that this expression could be null, which is kind of weird, and that means you have to check for that null everywhere. But I mean, you also have to check for null in here, so I guess that's fine. I guess that is fine. Okay, in any case, let's recompile this entire thing. So here's expr, and there we go. We have sort of like recursive dependencies. So what we need to do, we need to actually define expression before we use it in here. So before we declared it, and also get rid of this thing from here. Right, there we go. So this is what we've got. Okay. So, and now, when I'm parsing the table, right, when I'm parsing the table from the content, if I detected that this thing is an expression, I'm going to try to take this as an expression, and I'm going to parse expression cell value. There we go. So here is the cell value, and now if I try to run this entire thing, it will tell me that this thing is implemented. So we reached the execution like here. So when we're parsing the expressions, so the first thing we probably need to do, we need to tokenize the entire thing, right? We need to tokenize the entire thing. So to play with the tokenization, right, I'm gonna create a separate main in here, something like this, right? And let's do something like that. We might as well actually do something like parse expression SV A1 plus B1, right? And we want to see what's going to happen in here. So, and I'm gonna just return this kind of thing. So, how are we going to tokenize this stuff? Since we don't really need too much of the look ahead, right? Because the syntax is super simple. We can implement a function called next token, right, which accepts the input, right, maybe the source, and returns you the next token, but also it modifies the source, removing that token from there, right? So how are we going to do all of that? So first of all, we need to strip off, we need to trim all of the spaces before the input, right? So if you have something like A1 plus B1 and you have a bunch of spaces in front of these things, right? So here are a bunch of spaces, you want to strip them off. So the first thing we're going to do, we're going to do source, then SV trim, right? There we go, we trimmed all of the spaces from here. Right, and if the source is equal to 0 after that, we should probably return a null string, right? We're going to be returning a null string indicating that here is the end of the tokenization of our nation. And then after this thing, we know for sure that there is at least one character, and we can do the following thing. Source data, right? And if the argument, if the character starts with something like plus, we know that it's a plus token, right? It's going to be a separate token. So I don't think we need a switch in here. So we can do something like if this thing is equal to plus, we can just return that. So I think in SV we had a special thing. Starts with chop by delimiter, chop left. Yeah, you can basically chop an amount of characters. There we go. So you can say source, chop a single character out of that thing and instantly return it. So this is actually a pretty cool function, right? So what it does, it accepts the pointer to the string and the amount of characters you want to chop off, right? It modifies the string so it doesn't contain this amount of character in front of it, but it returns the string that it chopped off. So if you encounter something that looks like this and you know that it starts with plus, what you want to do, you want to remove it from the source and then return the plus. Right, so this is how it's going to work. Okay, if the source thingy is a digit, right, if it's a digit, we want to actually keep chopping until it's digit, right? So until it's not digit. I think for that we have something like chop while. I remember having, yeah, chop left while, and you can provide a predicate for this kind of shit. Yeah, I do remember that. So, and we can even return this kind of thing. So we're gonna return the source. So the source, and we'll have to provide isDigit, but unfortunately isDigit has a slightly different signature, so it may not work. We'll see. So we'll probably have to do something like boolean isDigit, which accepts the character C, and essentially it performs the conversion between these things like that. So we could use this kind of stuff like so, isDigit. All right. And so this way we chopped off the numbers, right? So we know for sure that this is a number. So after that, if isDigit actually is cell, right? Is cell source. This one is interesting. So cell, yeah. Cell can be only one character, A, B, C, D, whatever, and capital character, right? So that means we need to do something like source data. If this thing is that, right? If this thing is that, you can even say that it's between A and Z, so it's like between these things. If it is, right, so then what we need to check? We need to check that we have the next character and that that character is a digit, is a number rather, right? We need to check that it's a number. So I think I need to make a small break because my brain is starting to like fade away. So let's quickly make a break. All right, let's continue tokenization of our nation. So if the first thing is this, right? If the first thing is this, we need to actually continue taking the characters until they're numbers, right? You know what? I think I'm gonna like chop it off. Cell. Yeah. So we represent cell as a like 69. So I think when we're parsing this entire stuff, we should actually split everything. We need to convert A to 0, right, indicating a 0 row, and 69 to actually 68, because we're in the input, we're counting them from 1 to get closer to the Excel, but in the memory we're going to count it from 0. So that's basically the transformation of our nation that we need to perform, and because of that, the cell is not going to be string view. So I think we need to introduce something like expr cell, expr cell, and it's going to be basically row and column, right? So yeah. And as we parse everything, we're going to transform everything accordingly. I don't know why I keep saying that. It's so catchy. Like, holy shit. I'm so sorry for keeping saying that. All right, so in here, what we're going to do is going to be data, and I'm going to subtract A, and that will give me a value from 0 to 25, I suppose, right? So, and we can set, well, I mean, this is only a token. It's a le token. So this is a tokenization phase. Maybe we shouldn't pay too much attention in the tokenization phase yet. So yeah, I think this kind of stuff has to be done on the level of a parser. So we're going to introduce something like isName, right, which is essentially is al num, right, it's going to be C, right. So it's alphanumeric, or also we can support underscore just in case. Okay, so if this entire thing, we've got a raid from Dennis. Thank you so much for the raid, and the raiders, welcome to our epic Excel stream. For the raiders, for people from Dennis, I don't mind to explain what we're doing. Right, you can check out the thing we're doing in here if you're interested. We're implementing a mini Excel, right? So the idea is actually very simple. So we have a simple batch program that accepts a CSV file that looks like this, right? And it outputs something like this. So essentially it accepts the Excel table in CSV format, computes all of the expressions, resolves all of the dependencies, and gives you the result in the output, right? So that's what we're doing, and we're doing that as an exercise, right? So it's exercise in programming, essentially. So yeah, so far we implemented only parsing of the table itself, and we're in the middle of expression tokenization for parsing actual expressions. So yeah, that's what we're doing. Thank you so much for the raid. I hope the Dennis stream went well. I hope the movie's interesting, and yeah, let's continue programming. So yeah, recreational programming, exactly. So we're doing recreational programming. So I got the idea from the place I used to work, right? I used to work in a company that used this as the interview test. They would give this task to candidates to do over a weekend, and then they will bring back the solution, and then they will evaluate the solution and stuff like that. Unfortunately, I didn't have an opportunity to solve it because I was employed before this test was introduced, and now I'm taking it as an opportunity to actually try to do that, because I think it's an interesting, very interesting, exercise. Doing weekend task in a single stream. So, well, I mean, I'm already doing that for 2.5 hours, so I don't think, yeah, it would be better to have a weekend for this kind of stuff. Starting with xlib and eventually discover that one must set the xset focus to allow key board input to detect it by a given X window, and then fonts are no fun and I give up after 7 hours. I can imagine. I also worked with XSleep, and XSleep is no fun. To be fair, I worked with both Win32 API and XSleep, and I can tell you that Win32 API is better than XSleep. Yes, it is better. It makes more sense. Unfortunately, both of them are terrible. Don't get me wrong. Both of them are absolutely terrible. But Win32 API is better than XSleep. So yeah. A switch up left while. This one is going to be source is name, right? And in here, I suppose we can do something like fprintf. Std error unknown token starts with C.
Well, I am serial IBSDL2 would be far more easy, but your is the fun.
I don't think so. libsdl2 doesn't support phones, so. But I mean, there's always think SDL TTF. If you don't mind installing another library. So if you want to have phones with SDL, you have to have SDL2 plus SDL TTF, and SDL TTF depends on free type. So so libsdl2 by itself cannot do that, cannot cut it. Thank you so much for 15 months of tier 1 subscription, really appreciate it. But yeah, more libs, more trouble. Yeah, so it basically turns into left path situation. Yeah, dependency rat hole. Exactly. It goes deeper and deeper. So, right. So source data. Alright, so in this case, I suppose we're gonna be just returning. Actually, we're gonna be exiting with one. KKKK. I think it's a basically Brazilian detector, right? So Russians put the parentheses at the end of the sentence, and Brazilians laugh with a bunch of Ks, if I remember correctly, right? So there's always a way to detect a particular nation. All right, so we have that, and unknown token starts with that, and I think we implemented a simple tokenization of our nation. Okay, so what do we have? All right, so parse expression, and the thing I want to do is while source. All right, while source count greater than 0, right? It's greater than 0. We're gonna do printf svfmt svarg next token source. Might as well actually do something like string view le token. Right, so it's gonna be something like this, and here we got tokens. So the original expression, by the way, looks like this, right? So we can have C1, D1. I can put some spaces in here, and maybe I can even put 69 in here. And let's see. Everything seems to be tokenized properly. Yeah. Yep. To be fair, like, I don't think we need this particular thing in here. We can just treat it everything as the name and decide whether something is a cell or a number on the level of a parser. That way we can actually simplify the entire tokenization phase. Right, so the entire tokenization phase basically only looks for pluses. Right, so yep, that looks good to me, I suppose. Right. More or less. Don't see anything wrong in here. All right. So, but this is only tokenization. So now we need to perform the parsing. So we're parsing the expression. And when we are parsing the expression, I think we need to actually parse the expression by setting the source to via the pointer, right? Because it sort of consumes the source. Right, it consumes the source. And when you parse in the expression, I think the first thing we're trying to parse in here is plus. So we're gonna do parse plus expression, right? So provide the source, and here we're gonna create like expression. Well, I guess we can just return it like this, right? So this is a parse plus expression, and this is gonna be, I think, trans expression, the source. So the first thing we do in here, we were trying to parse left-hand side as the primary expression, right? Parse primary expression. So it's going to be source, right? And then we can try to get the next token. So it's going to string view token, next token from the source. Right, and if token data is not equal to null and token itself is equal to, if it is equal to, let's say, plus, we'll need to parse the right-hand side, right-hand side, parse plus expression. So we're going to be doing that recursively. Right, there we go. So, and after that, we'll have to allocate a new expression. So it's going to be this. So expression, let's actually put a pointer. This is going to be malloc size of a single expression, right? Expression kind is going to be expression kind plus, right? So this is going to be that. Then expression as plus, left-hand side is going to be equal to left-hand side in here, and right-hand side is going to be equal to that, and then we just return the expression. So if we didn't have plus or anything, we simply return left-hand side as the thing that we managed to parse. So this is basically how we parse the plus. So this is actually a pretty good song. I really like it, so I'm gonna actually upload it. All right. Okay. So expr and what we need to have in here is parse primary expression, right? So it's primary expr string view source, right. And this is where it becomes really interesting. So we need to get the token, right? So this is going to be the token, next le token. Right, so here is the next le token, and if the token starts with something like, well, not really. Right, first of all, we need to check if the token count is greater than 0. If it is equal to 0, that means we reached the end. So we need to report an error. std error, expected primary expression token, but got end of input, maybe end of input. So this is how we're gonna report this kind of error. There we go. So this is the token, and the next thing is, so now we know for a fact that token has at least one character. So we can take this character and check if it's a digit. Maybe not. Maybe yet again, we can try to parse this entire thing as as a number. If it is a number, that means it's a number. If it's not a number, we can try to parse it as a cell. Right, that's essentially what we can do. Parse it as a number, parse it as a cell. So, and we know that to parse it as a number, we need to do str to d, and yet again, we'll need to have this temporary buffer thingy. Right, so I'm gonna copy paste it here just to save some time. So this is a temporary buffer. So this is not a cell value. This is more of a token. There we go. Then we put that into a temporary buffer. Then we're trying to parse this entire thing as a number. So this one is going to be expression. Malloc size of expression. Right, so we're just allocating this entire thing. Right. So this is a temporary buffer. And for the expression as number, we're going to try to do that. And if it is in fact a number, we're going to set expression kind to expression kind number. Otherwise, we're going to try to parse it as the cell, right? So assert 0 not implemented cell, right? So this is the cell. Let me see if this entire thing compiles to some extent. So this one is SV, right? So another one is going to be cell value. Oh yeah, okay, that makes sense. Because if you parse it, yeah, we can consume it. There's no reason to not consume it, sure. So, and here we have this thing, incompatible. Oh yeah, when you try to parse this thing, you have to first like save it to string view source, right? And because it's an initialization, we can just do static in here. So then we have to pass this by a pointer. So is there anything else? Semicolon, sure. Okay, and we have control reaches this thing. Okay, that's fine. Can I just do something like this too? Yeah, still control reaches. I see. So it means here we just need to return the expression. Okay, so yeah, everything looks okay. Cool, cool, cool. So we almost finished, and now we need to parse the cell, right? We need to parse the cell. So how are we gonna parse the cell? The cell is supposed to have a format of a something something, right? A something something. So is there any way to check that something is upper? Is there something like is upper? There is in C. Program is. Interesting that. Why doesn't it refer to CPP reference? Did Programmis actually paid a lot of money to Google to be here, or do they have a genius SEO, SEO optimizations, optimizers? It's kind of strange. I don't quite understand. So, so CPP reference has a bad SEO, which is kind of strange because it's the most used website by C++ programmers, right? So Google is supposed to detect that and probably redirect to something. It's like Wikipedia. So for me, CPP reference is the same level of a website as Wikipedia, right? So if you have anything related to C++, C or C++, I expect CPP reference in there. And if Google doesn't show me that, well, it failed as a search engine, in my opinion. They always search using site. Oh, okay. Oh, Sermon, what's up? How are you doing? All right, so let's continue. So the first thing, it starts with the characters. So is upper, right? CPP reference. Is upper. No, that's precisely what I wanted to have here. Is upper token data like this. So if it's not that, we can report an error. Printf std error. Cell reference must start with capital letter. Right, so that's basically what we're gonna have. Exit 1. So we don't report the locations of the errors because that will take, time. So I'm just trying to save on time. So because of that, so actually this defines a column, right? So that means I need to do expression kind cell, right? And then expression as column has to be equal to token data minus a. There we go. So after that, I should be able to chop off this thing. So I'm gonna chop, I think left, right. So we're gonna provide the token, and we're chopping off one character in here. So, and after that, I need to convert. The rest of the stuff, and there are to a number. I need to convert it to a number. And I need to use this weird trick with TMP buffer yet again. So you know what I'm thinking? I'm thinking that I'm gonna create special wrappers, something like SV str2d, right? Which essentially just accepts this thing, right? So SV and returns you double, right? And it will just do this kind of stuff for you, I suppose. But then how will it indicate that it succeeded or not succeeded? We can basically accept the result like this and return maybe Boolean. All right, so we put that into the buffer. Right, then I do str2d like so. So this is going to be double result. Right, so it's going to be double result. And if the end pointer, that means it's a success, right? So if this thing happened, this is a success, and I might as well actually return it, right? So yeah, that's actually pretty cool. So str2d, and this sort of like a TMP buffer is going to be encapsulated here, and that way I can replace all of that quite easily, right? Can I? I can put if like this, so this is going to be SV. So the input in our case is basically token, and the result into which we put in it is going to be somewhere here. Right, so it's going to be something like that. So we don't need that anymore, that anymore, we don't need that anymore, that anymore, that anymore. Okay, that's actually perfect. I really like that. Right, so I just shoved it under the carpet. Right, and then in the future maybe I can, implement something better. All right, so let's go to another place where we do ascend printf and some other shit. Yeah, so it's going to be SV str2d, and I accept the cell value, and the result is going to be located in here. Right, the result is located in here, and we can remove that, and we can remove that. Okay, so now we're starting to compress the code, right? So my favorite part of any development, I just pile the copy-paste on top of the code until pattern emerges, and then I just collapse this pattern, and that feels beautiful. That feels absolutely beautiful. Okay, so can I just recompile this entire thing? And what do we have in here? So token, this should not be called token. Quick replace token with SV, boom. Anything else they want from me? Result. Well, this thing I think has to be something like that. Well, I mean, yeah, we can call it like this. It's gonna be out, and if out result. Right, there we go. So this is gonna be working. And pointer, and we didn't specify any end pointer in here. I can specify it, and ptr null. So is it going to work now? All right, so what do we have in here? As cell. There we go. Anything else? Cool. All right. So, and the reason why I sort of did that is because I want to have a similar function, but for the integers. So is there something like str to I? I think there was something 3bsd. You have to use a to I suppose. Right. You have to use a to I, unfortunately. There's str to L. Okay, so maybe that's what we want to have in here. Str to L. Yeah. Okay, so that means we're gonna have str to L, and this is gonna be long int. So str to L, and I suppose it's a very similar thing. Long int. Right, is it gonna compile? Str to L, so it has to be. What are you complaining about? Too few arguments. Oh, you also have to provide the base. Okay, that's fine. Compilation. Okay. So, yes, fucking this. So we're gonna have like long int row, right? And sv str to L. We provide the rest of the token, right? The rest of the token, and essentially that row, right? And if this thing didn't succeed, this is straight up like this: error, cell reference must have an integer as the row. I don't know how to say. Cell reference must have an integer as the row number. I'm not sure if it makes any sense, but okay. So, and in here we're gonna do token, actually expression as cell row, and we're gonna convert this entire thing to row like this, right? Because this is a size t. Incompatible type, so you accept this kind of thing, and of course in here we just need to return expression. All right, so interestingly, maybe we can move this entire thing simply outside of this thing, right? So, and now, okay, everything seems to be compiling. Okay, so we supposedly we implemented parsing. Supposedly we implemented parsing, but we need to, I guess, demonstrate that somehow. How can we demonstrate that? We can go into the debugger. We can go into the debugger and see if it actually, you know, after you parsed everything, if it actually contains anything. So you also have to do something like export. We can give it a try. Why not? So I'm gonna do no build GDB. We're gonna break on main, we're gonna run, and we're gonna take a look at this thing. All right, so if I print export, it does contain something. So, and here's the expression that we tried to parse in here, right? So that's precisely the expression. So we have a kind plus, all right, we have a kind plus, and in the plus, we have a right-hand side and left-hand side and right-hand side. Yeah, it's already kind of inconvenient in my opinion. So it would be better to have a function that prints the expression, right? So parse parse expression, right? So parse expression and have something like dump expression, expr. So you dump it into a particular stream and you accept the pointer to the expression, right? And then you switch upon different kinds of the expressions. Also, since it's a tree, you may want to do something. We can have a level in here, so it's going to be level. Right. So it's going to be expr kind, right? And case expr kind number, right? And maybe we can do something like printf. I forgot how to print like space in front. Does anyone remember? I remember that I did something like that in STB, in Bosom specifically. So I can grab for dot edges. Yeah, dot edges. As dot edges. Not really. Oh yeah, this is how we do that. Yeah, it's just like dump. So this is gonna be that. Level 2 and spaces. So if I do a number, 1, 2, 3, so we can do fprintf stream, and I can do something like number, lf expr as number, right? So this is expr as number, and then we're gonna break case expr kind cell. So in case of a cell, it has to be something like printf stream cell zu, right? Expr as cell row, expr as cell column. There we go. And then we're gonna actually break in here. But in terms of the plus, right? So this is gonna be plus fprintf stream plus, right? And we'll have to do a couple of more things. So it's going to be dump expression stream expression as plus left hand side with level +1, and then also right hand side. There we go. That's what we're going to do in here. So that will dump the whole AST. By the way, Columbetka, there is no need to time out these people anymore. I'm actually not really following the chat anyway, so don't worry about it. Thank you so much then. Okay, so all right, so it's gonna be S, and all right, long. This one is interesting. Do I have to do something like long inside int expects int? Okay, so maybe we're gonna do actually int in here. Why not? And here's expression, and I can dump expression. There we go. Okay, and I can specify std out. I can specify std out, and was it dump expression? Oh yeah, also you have to put a level in here. There we go. So we're gonna run this thing, and I forgot the new line, of course. I forgot the new line. So let's put it like that. So it's gonna be new line. Okay, so that's what we got. So if we take a look at the original one, right? So it's gonna be something like this. This is what we have. We have A1, B1, then 69, then C1, D1, and all of that is summed up. So the row 1, right? The row 1, but the column is 0. Yeah, so first one is column, the second one is row, right? And this is because in Excel, rows are like have characters and stuff like that. So I think this is correct. Then we have a number, and yeah, we have an AST. So this is AST essentially, which is pretty pogue. I'm not gonna lie. You can already try to evaluate this entire thing. So okay. Now we can probably get rid of this entire thing, right? So, and when we are parsing this stuff, when we're parsing this stuff. To parse table. Is everything okay? All right. So when we parse the table, we parse the expression, and okay, so everything is already working as intended. I think we've done it. Unknown token. Oh yeah, this one is interesting. So if it starts with 1, we have to chop SV chop left cell value 1, right? And there we go. So we parse everything. And even expressions, but expression is an AST, right? So that's the problem. Expression is an AST, so we cannot easily print the AST inside of this thing. But one of the things we can try to do, we can actually sort of flatten it out, if you know what I'm talking about. Right, we can get rid of these things, and as we print the these cells, we can print their rows, right? So something like row cell ZU, right, it's going to be something like that, and this is a row and column, right? So here is the cell, then we print an expression, so this could be a new line, and then we can dump expression std out. So the expression is going to be cell as expression, and we're going to have like a 1 level of indentation just to indicate that, and a boom. So that's what we got, and of course I forgot new lines in some places. Right, so let's get rid of this thing. So here are the new lines. There we go. So we have cell 00, text A, cell 01, text B, numbers, and then expressions. And yeah, so this is basically the dump of this thing. That's what it is. It's literally the dump of that stuff. So that's pretty cool, I think. What do you guys think? So we can do something like plus C1, right? And yeah, there we go. So now we have a little bit of more nested stuff. Yep. So that's pretty pog, not gonna lie. So the next thing we want to do, actually, we want to implement the evaluation engine. How are we going to be doing that? We're going to add additional information to the cell, right? Cell, there we go. So we're going to have a value of the cell. And the question is, what's going to be the value? It will actually depend pretty much on what kind of cell it is. So if the cell is, I think it only makes sense for the expression, so that means we'll have to go to here. And if the cell is an expression, I think it should have an information whether it's already evaluated or not, or something like that. So it feels like we need to introduce another structure called cell expression, right? So this is what we're going to have in here, cell expression, and cell expression contains the expression and information whether it's evaluated, right? And the value, right? So it also should contain the value that got evaluated. So it's going to be like the whole thing in here. Right, and the reason we need to do that is that because expressions depends on other expressions, right, and we don't want to reevaluate them multiple times. So yeah, let's actually go through the compilation errors and modify everything. So we have a parsed expression, so that means here, oh man, okay, so I think cell, we have expression cell and cell expression. That's actually really funny. Like, we literally do have expression cell and cell expressions. Oh shit. Okay, that's funny. I didn't expect that. But it is what it is. I think it's fine. I guess it's fine. So this thing should be called AST, by the way, I think. I think this thing should be called AST. So this is AST, and that's what we're parsing in here. And so this kind of stuff, All right, so parse, we need to mem set some of these things, right, because they're not properly initialized. Expression AST, right, so dump expression AST. Yeah, it kind of works. So the thing I need to do, I need to be super careful, right, when I allocate, I also better mem set this thing to 0, right, malloc, same shit. Zozin, have you heard about calloc? Zozin, did you know that calloc automatically zeroes out everything for you? Zozin, you need to know that. I'm pretty sure you never heard about it before. Zozin. Okay, so size of cell, I suppose. And where is another malloc? Okay, so this is fine, there's no need to that, and I think we mem set everything everywhere where it's needed. Okay, oh by the way, this one is actually incorrect. That's why you should use calloc Zozin. That's why. Oh wait. We actually said it twice. I think I made a mistake in here. Okay. Alright, so looks good. Oh. Alright. What was there? Yeah, I wanted to do the evaluation of our nation, right? Cell export. So essentially, we now want to iterate through each individual cell, and if the cell is an expression, we want to just evaluate that expression, and while we are evaluating that expression, we're gonna trigger evaluation of other expressions and so on and so forth. Calloc also zeroes out the memory. So calloc function allocates memory for arrays and elements, blah blah blah. The memory is set to 0. So yeah, that's what it says. Set to 0. All right. So let me see. Okay. So now, if cell kind is equal cell kind expression, and cell as expression not evaluated. Right. If this entire thing is not evaluated, what we do is table eval cell. We provide the whole table. Right, we provide the whole table, and we provide the row and column, right? So there we go. So we say evaluate this specific cell. Please. Thank you. Thank you. So I'm thinking, what's gonna be a better way of doing that? So maybe it would be better to actually give it the pointer to the cell, right? So you have the pointer to the table and pointer to the cell, right? So, and then you try to evaluate the cell and so on and so forth. Yeah. Right, so you evaluate this stuff. So we accept the table, right? So, and then we accept the pointer to the cell, right? And interestingly, we need to switch upon different kinds of the cell, right? So it's going to be cell kind, and if cell kind, well, in case of the expression or like number and text, we don't have to do anything because they already contain the values, so that's fine. So we're not going to do anything in here. So I suppose we're specifically looking for if kind equals cell kind expression and cell as expression not evaluated. Well, because of that, it feels like I can just get rid of this condition like this. So yeah, I think we can completely get rid of this condition. So you iterate through each individual cell and you just evaluate that cell. Nothing particularly special. If it's not evaluated, it's an expression. So what are we doing? We're trying to evaluate the specific expression. Table eval expression. So we provide the table and then we provide the expression that we're trying to evaluate. All right, so this is going to be a separate function. Table eval. Well, this thing is supposed to return something. So that means we're going to set expression to evaluate it true, and then we're going to set as expression value to whatever table eval expression returns, and it's supposed to return double actually. Right, so it's going to be table, and expression. There we go. So that's what we have in here. And so again, it all depends on the kind of the expression, right? So if the kind of the expression kind number, it is in fact very, very easy. You just do expression as number, and there we go. Here is your value. There is nothing that needs to be done here. Then if expression kind is cell, you need to find that cell, right? So we need to query that. So table cell at, okay, so it means I need to get the cell, table cell at table. Then I take the expression, yeah, I interpret it as, what is this, cell, and take the row, and then I take the column of this thing. Might as well actually, no need to do that. I think there's no need to do that. So we have a cell. And depending on what kind of cell is this, so if the kind of cell is a number, cell kind number, we can just simply return cell as number, right? So if the cell kind is a text, right, we can say something, we can actually throw an exception. Well, in C there is no exceptions, but we can throw an error. fprintf std error, cell zuzu, cell zuzu, text cells may not participate in expressions, right, in math expressions. There we go. Or maybe we can just always return 0 in that case, right? So for an authentic Excel experience, let's return 0. No, maybe 0 divided by 0, so we're gonna do none, you know, just to piss off the user. So if you try to like use text cell in a mathematical expression, it's just gonna be none, I guess, because it's not a number. It makes sense, right? Is there something like none for C and C++? I don't know, maybe. But it would be better to actually crash, I think, right? Because it's a batch program, so... oh my god! Come on! Just bring back the... Emacs is dumb. Okay, so I'm gonna just return this stuff. fprintf std error. Text cells may not participate in math expressions, and I'm gonna just exit with 1. All right, and if this cell is another expression, we'll have to evaluate that cell first, right? So let's quickly do that. So we're evaluating that just in case. So it's gonna be table cell. I might as well. So we have a mutual recursion in here, right? So there's a mutual recursion between table eval cell and table eval expression. So that's why they need to know each other. So we evaluate this cell, right? And then we know for a fact that it's All right, it's an expression, so that means I can just simply return cell as expression value. There we go. So there's nothing needs to be done here. And okay, if it's an expression number, it's expression cell. What was the other thing? Oh, there was also plus. I completely forgot about that. Okay, so there's also plus. So case expression kind plus, right? So this is going to be the plus. And in here, essentially, we are evaluating two expressions, right? So we need to have left-hand side and right-hand side. So double LHS, expression as plus LHS, RHS, and then return LHS plus RHS. There we go. So that's what we're gonna do here. Okay, do we have anything else in here? So expression kind. So let's not run it yet because I'm not 100% sure. Has to be a pointer. What else do we have in here? IST. So if I'm trying to evaluate the cell, I'm doing it like that. Okay, okay, so now everything seems to be compiling, which is nice. So if I try to run it, let's see if it crashes. It didn't crash, it didn't hang, which is already very nice. I'm really happy. So the next thing we can try to do is iterate through everything. Maybe we're already iterating through everything, so yeah, we might as well actually just do something like this. Switch cell kind, right? Switch cell kind. If the cell kind text, right? If cell kind text, we're gonna do printf sv fmt, right? Sv fmt sv arg cell as text, right? So this is going to be cell as text, and there we go. So then we're going to break this entire thing. If it is a number, if it is in fact a number, printf lf cell as number, and then I'm going to break this entire thing. Right, and then cell kind expression, it's going to be pretty much the same as cell number, but we're going to do as expression value because we know for a fact that it was already evaluated. Right, it was already evaluated. So after that, we need to print the bar, right? We can print something like this in here. But if the value is the last one, we shouldn't print the bar, I think. I think we shouldn't do that. I think we shouldn't do that. But how can we detect that? So if column is like not equal to tables calls -1, right? So if it's not the last one, then we're gonna print it or something like that. So and then we put a new line in here, right? Or maybe if it's less than that, we're gonna print it, but if it becomes equal to that, yeah, I think that makes a little bit more sense. And that will essentially print everything. Okay, oh, almost. Table columns, and here we need to have a semicolon, and so but the problem is it doesn't take into account the circular dependencies, right? So for the circular dependencies, we need to implement the additional code, but chat, we have a thing that does the thing. 3 hours 20 minutes. So yes, of course it doesn't really check a lot of things, so everything works because of the happy path, and whatnot. It would be nice to have like a proper error reporting and stuff like that. But yeah, I don't know. Week, it's not really a week, it's supposed to be weekend, by the way. And it's not particularly finished. It's just like a rough sketch of how I would do that, but it definitely requires a little bit more polish. Right, if an error happens somewhere, it will basically tell you cell reference must have an integer as the row number, but it doesn't tell you where exactly that happens. That's kind of lame, if you know what I'm talking about. Right, so here, you see, this is just a string. Well, yeah. So okay, so let me try to do the following thing. Right. So it's gonna be 1. Oh, that's actually very interesting. All right. So, I think I want to make a small break, by the way. I think I want to make a small break. And after the small break, we're going to try to address the circular dependency situation, right? So to address the circular dependency, I think we'll have to introduce like more information into the cell, right? So where is the cell expression? So we have evaluated, but instead of evaluated, we're going to have like different statuses, right? So whether it's not evaluated, currently evaluating, and evaluated. So essentially, while you're traversing things, you mark the currently evaluating cells as evaluating, and if while traversing things around you encounter evaluating cell, that means you detected a circular dependency, right? So, and that means you'll have to report that appropriately. So that's the way I did that, at least in BOSM implementation, because in BOSM you could define bindings depending on each other, and I needed to actually keep track of the things like that. So I think I'm going to use a similar approach here as well. But all of that is going to be done after a small break. All right, so let's quickly implement what I wanted to implement in here. So first, maybe we want to actually demonstrate the situation. 0, 1, 2. Okay, so this is essentially A, right? Row A, but the column, well, I mean column A, but row 0, 1, 2, 3. Right. So this should hang because A3 is this thing, right? So, well. And this one is, I suppose, B3, right? So B3 is this cell, and A3 is that cell. Okay, so I think that makes sense. All right, and if I try to run this entire stuff, it actually worked, surprisingly, and the question is why. I think I know. Evaluated equal to true. Ah, that is very interesting. Look, so we've got a donation. Just a second.
List favorite programming lang. Greetings from Finland.
Just a second. Kahava, I hope I pronounced your nickname correctly. Least favorite programming language. Greetings from Finland. Thank you so much for $10. Least favorite programming language. This is a good question. Which language I tried a lot of languages, but which one did I hate the most? Ooh, this is a good one. Perl wasn't that bad, actually. Perl wasn't that bad. 1C. Yes. 1C. Or 1S. It's a Russian programming language. So it's a freaking classic. Yeah, so for a Russian it should be no-brainer. Yes, 1C. 1C programming language. So it would be better to actually search for that in Russian. Язык программирования. Пример. right? So like you can't even find anything interesting in English about that language, right? So you have to actually search in Russian, and this is how the language looks like, right? So and what's interesting is that what they this looks funny really. What they did, they took Visual Basic. They took all of the tokens of Visual Basic and they translated it in Cyrillic, and they implemented their own like system that interprets that language, and that system is absolutely horrible. And in the university I had to program in this language, and it's like holy fucking shit. Like I never want to program it again. So that's basically my answer. This is my least favorite programming language. You probably never heard of it if you're not from Russia. So it's a fucking nightmare. So yeah, and there's a lot of people in Russia who program in that language. So you can even have a pretty successful career as a 1S or 1C developer. Well, it's better to call it 1S. Is it better than PHP? Nah, not really. Well, I mean, it could be better in the sense that it has a static typing at least, and PHP doesn't, but the whole system, the whole 1C system is actually very Papaga. So, yeah. Looks like MD5 sum. Yeah, if you don't understand Cyrillic, it does look really cryptic. You know what's funny is that it also supports Latin tokens. Right, so you can actually make it look like Visual Basic and it will work, but nobody in Russia is using those tokens, and nobody outside of Russia using this language either. So what's the point of the English tokens? I don't understand. Right, because again, inside of Russia, nobody who programs in C, like quite a few people who programs in C speak English, and even if they speak English, they have a code base that is completely in Cyrillic, and nobody is using it outside of the countries who speak Russian. So, yikes! I don't know. It's really weird. So yeah, thank you for the $10. Really appreciate it. Thank you. Okay, good. What we need to do? Oh yeah. So the reason why it didn't hang is because before, if I need to evaluate the cell, before actually evaluating its expression, I instantly set it to true. Right. So if I set it after I've evaluated it, I think it's gonna hang straight up. Yeah. The Stack Overflow. I think it's a Stack Overflow straight up. So. I wonder if Clang can tell me if it's a Stack Overflow or not. So we can actually go to CC and let's actually use Clang, right? And Clang has like memory sanitize or something. Clang sanitize memory flag. I forgot the flag. F sanitize. Yeah. So it's gonna be F sanitize memory, and we're gonna put this flag in here. Right, so it's gonna be something like this, F sanitize memory. All right, so, and, oh yeah, it has to be a flag, of course. Yes, and it actually brings something. Stack Overflow, okay, so this is a straight up Stack Overflow. Deadly signal, would you look at that? It's a very deadly signal. Stack Overflow. Maybe I should use Clang actually. Clang looks nice. Alright, so that's precisely what happened, but what's funny is that if you try to do something like this, it will try to access the value that is not fully evaluated yet, and it's totally fine, but it's completely incorrect actually. So it has to be done somewhere here. So what we need to modify, we need to change this value from evaluated to something that I like to call evaluation status. Okay, so we're gonna introduce enum, right, cell eval status, right? So this is eval status. Cell unevaluated. So initially cell is unevaluated, then it's evaluating, and then it's evaluated. Okay, so I think I'm gonna actually call it slightly differently. In progress. right? Because it's super easy to make a mistake between evaluating and evaluated. So let's actually call it something like in progress. I think it's going to be way better. And in here we're going to have maybe it's not going to be essentially eval status. Maybe it's going to be eval. Nah, let's go like this. Eval status. Eval status. Status. There we go. Since 0 is unevaluated, it's going to be like that initially. Alright, so let's go through all the places. Okay, if table eval cell, you need to evaluate a table eval cell. And it is kind of an expression. You need to take a look at its status, right? So we're going to switch on status, right? So here's the status. And I suppose if the thing that you're trying to evaluate is currently in progress, this is where you want to throw an error, I think. std error, right? std error, error, circular dependency is detected, honey detected, and then we're gonna do this thing. All right, so after that, if it is already evaluated, there's no reason to do anything, right? If cell status, actually as expr status evaluated, there's nothing to do, so we need to look for unevaluated, right? Unevaluated. If it's not evaluated, what we're gonna do in here is quite important. We're gonna set this status to in progress, then we're gonna evaluate it first, right? We're gonna evaluate it first, and then we're gonna set the status evaluated, right? There we go. So that's how we're gonna be doing that. Right, so if it's in progress, this is straight up error. You're trying to do something that is currently evaluating. You cannot do that. If it's unevaluated, we mark it as in progress, then we evaluate this thing, and then we set it as evaluated. Cool. So, and I know that we also look at the status somewhere in here, right? Somewhere in here. This one is rather interesting, so maybe it's gonna do something, but yeah, let's take a look at the errors that we have. So if I remember, there was like 2 errors, and this is gonna be like that. Circular dependency detected. It detected circular dependency, so all right. So, and if we go back to the original thingy, right, so it's gonna be input CSV. So I want to kind of save this thing just in case, and I'm gonna replace this thing with that. What the fuck, Emacs? What the fuck is wrong with you? Emacs sometimes copy paste the styles of the text as well, so it's not supposed to be like that. Yeah, we need to switch to different. Yeah, so this is the text. Right, if I try to do that without the circular dependency, it actually worked. But I mean, yeah, there's a new line in here that needs to be fixed. Yeah, so it works, and it also detects circular dependencies. All right, that's pretty pogue, not gonna lie. But I guess that is the entire thing, pretty much. So, but the only thing that lacks is proper error reporting, right? So it would be nice to actually report precisely in a place where the thing has happened, or at least instead of throwing an error, just put some like error value in there. That would be interesting as well. But we're already working on it for almost 4 hours, so I don't think we're gonna do that right now. So the thing I'm gonna do is I'm going to simply commit whatever we have already, right? So okay, I accidentally implemented the whole mini cell. I didn't expect that. Okay, so what do we have in here? So we also have that. Implement the whole mini cell. Right, of course it's lacking. You can find the means. I don't know what this means, so I'm sorry. I'm out of touch with Twitch memes. I don't watch Twitch. So mini cell. All right, you can find the source code here, and if you're watching on YouTube, you can find the source code in here, mini cell source code. So the things we can have in here. So what would be nice to have? What would be nice to have? I suppose a TMP buffer. Right. I don't even know what's the problems. So the only problem I see in here is probably error reporting, right? I'm a robot.
22 FAH freaking Montes.
Thank you so much for 22 months of tier 3 subscription. Oh my god, thank you, thank you, thank you, and welcome to our epic mini cell club. Right, so tier 3, holy shit, thank you so much, really appreciate it. Okay, errors don't report the location in any way. It would be nice to at least know what is the cells, what is the coordinates of the cell that caused an error, right? So yeah, it would be nice. So I'm gonna create an issue for that specifically. And apart from that, so though it's basically an exercise, right? So it is basically an exercise. So I don't think it has to be like super complete. And this is an exercise that is supposed to be finished in a weekend. I just, you know, hacked it together in 4 hours. And I guess that's what's supposed to be here. And also it doesn't support more mathematical expressions. Yeah. So I just remembered. All arithmetic operations with precedence and parentheses. So I cut a lot of corners in here, right? So for instance, our parser does not support like minus, multiplication, and also precedence between them, and also parentheses, because again, this is supposed to be done over weekends. So I took a lot of shortcuts. So looks like a pretty good weekend of project actually. So I really enjoyed it. Again, for those who just joined, this is an exercise that was used in a company I used to work at as part of the hiring process. So they would give this task to the potential employees and like over a weekend, and after a weekend they're supposed to send the solution and they would evaluate the entire solution. So that's kind of the point of this thing, to be like as comprehensive as possible, right? So here you have to parse CSV, here you have to parse mathematical expressions, here you have to do a little bit of a graph theory because there is connection between these cells and stuff like that. You need to detect the cycles and whatnot. You have to be super careful. This is an exercise in reporting errors, right? Because if an error happens, how do you report that? And it's also exercise in the software design. How would you design such a thing? It's actually a very cool exercise. I really enjoyed it. So it evaluates so many different skills of software developers simultaneously. It's actually quite great. So yeah, so I could continue developing this thing, but I'm not sure if there is any point. I just wanted to try it and see if I can do that. I can clearly do that. I just need to add more things in here, just here and there, just polish it up, and maybe I could get a job at the company that I used to work at. Anyway, so I guess that's gonna be it for today, boys and girls. That's gonna be it for today. Check out the source code of the project and check out the description. So I put all the links there that we discussed in the stream. Thanks everyone who's watching right now. I really appreciate it. Thank you for all of the donations, for all the subscriptions. I really appreciate that as well. That is very cool. And I gotta go. So maybe we should rate somebody. What do you guys think? Should we rate somebody? Is anyone streaming anything interesting on the science and technology section of the goddamn streaming platform that is called Twitch? Olympians. That's a good one. Alright. So we need to wait until the Twitch loads up because it's a very fast website. Quantlet, no, Node.js. Game dev. Python, Django, GraphQL. Oh my god, it's actually stuck. Live coding C++, C++ 23. Oh my god, C++ 23. This is actually pretty cool. Let me see. 20. Wait, is that a thing? Is C++ 23 a thing?
And things like that. I feel like duplicative functors are a lot more useful in languages which have those features. Maybe I'm wrong. Maybe there's some really good.
All right. So let's rate them, I suppose. Zozin. Jadra789. Thank you so much for Twitch Prime subscription. Thank you, and welcome to Epic Excel Club. I suppose, I don't know. Is C++ living in the future? Of course. It is more advanced than Rust. God. All right. Twitch, why are you so slow? All right. I'm still waiting for my rate thingy. Okay. Get ready for the rate, boys and girls. Get ready for the rate. And I see you all next time. Love you.